Hello, my name is Burnam, and I will be sharing my action research study. This study is highlighting the integration of technology in math classrooms. Also, technology can be used in 4 categories: tutorial, communication media, exploratory environment, tools, and programming language. The area that this study will highlight is exploratory environment, tools, and tutorial. The resource highlighted in this action research is Study Allen. Study Allen is a web-based instructional site that assists students in their reading and math skills. So my research question will be, how does the use of Study Allen, a web-based instructional site, promote middle school mathematics students' understanding and attitudes while solving mathematical concepts? Here's a table of my themes and resources from my literature review. And my themes are mathematical web-based instructional resources and, again, the impact of technology has on students' attitude and achievement. All 3 resources shown on this page have positive results. For example, one source contends that technology is essential in teaching and learning mathematics. It influences the mathematics that is taught and enhances student learning. Another source suggests that successful and effective use of technology for the teaching and learning of mathematics depends upon sound teaching and learning strategies to come through an understanding of the effects of technology on mathematics education. And finally, research also shows that there has been a shift from using computer technology to promote drill and practice in traditional classrooms to using computer technology to create interactive learning environments in mathematics classrooms. Here are some definitions that I wanted to share. Exploratory environment, which seeks to encourage active learning through discovery. Tutorial pertains to programs that directly teach mathematics by setting up a stimulating environment where information, demonstration, drill, and practice are provided to students. And tools. Tools serve the technological purpose to make teaching and learning fun, effective, and efficient. For example, Geometer Sketchpad, Capri Jr. are 2 well-noted web-based instructional sites that give students that hands-on and visual opportunity to enhance their understanding of various mathematics concepts. Again, to share some more results for one of my themes, I have the impact of technology has on student learning environment. Another source says that web-based instruction has the potential for positive outcomes, social interactions, changes in teaching styles, effective teaching, increased motivation, and enhanced learning improved by integrating technology in their learning. Another source says that technology promotes collaborative activities and enhances the degree to which classrooms are socially active and productive. And another interesting source reveals that web-based mathematics assessment and practice enabled participants who had a high level of anxiety in learning math to recognize their scores instantly. Thus, they had more control over their learning and felt less anxious about doing math. Here is a table, which again shares my goals and my themes. A good resource that I found, web-based instructional site, is Intel Math Apprenticeship. And evidence showed that after 6 weeks, students' responses had improved and they put more effort into answering difficult questions. My next goal, to measure the effectiveness of technology, of the integration of technology has on student achievement. Another source shares that students who participate in computer-connected learning networks showed increased motivation, a deeper understanding of concepts, and an increased willingness to tackle difficult questions. So here's another way, or some more sources that indicates that technology has a positive impact on student learning. And my table goes on, is continued. Another prominent, well-noted, well-based instructional site is Alex. This program scaffolds instruction by having students travel through an individualized program based on their initial assessment and marks their progress on a pie chart, which again gives students a chance to see their progress. Another well-noted, well-based instructional site is computer-supported collaborative learning, which is a strategy for students to team up in an online environment, work on virtual math teams to discuss and solve math problems, using an interactive and shared whiteboard. So this seems like a good tool to enhance students' the ability to discuss at higher levels of thinking. They can help their classmates, and they can also see problems being solved from different angles, from different points of views. And again, to measure the effectiveness of technology, of the integration of technology has on student achievement, students shared that computer made mathematics easier because it offered more instruction, more examples, and were more readable, and gave them opportunity to correct their mistakes. Here is my data confidentiality of human subjects. The subject for this study includes 64 6th grade students and 4 math teachers. I will use Microsoft Word to store the names and scores of students' fall and spring math scores. Also, students' names will be in the form of student ID numbers. I plan to protect my data results by encrypting the file using Word. Also, I sent home a backpack note for students to gain permission from their parent/guardian in completing the survey. So here are my methodology and and procedures. My action research applied a group comparison in the form of mixed methods, qualitative and quantitative data collection and analysis. The instruments used in this study are teacher and student Likert surveys and students' beginning and mid-year MAP scores. And again, once I collect all of my data, I plan to use some features in Excel to analyze my data, find the median, and then transform those data points onto different graphs. I have included a line graph and bar graph. And also, I will tally up students' and teachers' responses from the surveys to get a final outcome. So next we have a list of my students' fall MAP scores. And if you notice, the red line is the median. So for the fall, the median was 196, and 32 students scored above the median. Next, we have the spring MAP scores, and if you can tell, the median increased from 196 to 200, and this time 54 students scored above the median. Here we have a graph of students' growth scores, and the most growth we saw was between 5.7 and 12.6 points, and around 24 students scored that much. And also I did a correlation comparison to see if the time that each student spent on study hour resulted in positive scores or positive growth. And my correlation was at a point 30, 30 hundredths. So that's an indication that more time spent on study Allen did not necessarily mean that student scores increased. Some may have had, but majority of the student scores did not increase based on the time they spent on study Allen. Here are my survey results. And I'll start with my student surveys. 50% of the students said they felt like study Allen built up their confidence in their math skills. 58% also felt like study Allen helped to reteach the concepts that they misunderstood. 35% felt like study Allen did not improve their skills, while 52% felt like study Allen was engaging, and 74% felt like that study Allen, the feedback provided by study Allen, was helpful. As far as my teacher surveys, all 4 teachers either scored agree or strongly agree for the following. They said study Allen identified student struggles with various math concepts. They felt like study Allen was friendly, user-friendly while tracking data. Also, they felt like study Allen improved students' understanding of various math concepts, and they felt like study Allen also improved students' confidence while solving math concepts. So here's a table for my p-value, and according to Mertler, it says that in order to reject the null hypothesis, which for this study will indicate no difference between fall and winter math scores will occur from using study Allen during math classes, if my p-value is less than 5 hundredths. And the p-value for this study is less than 5 hundredths. It was very, very low, 0.00000011, which suggests that a significant difference does exist between my fall and spring scores. So study Allen did have an effect, a positive effect on students' achievement. Again, here's a recap of my results from the surveys. Now here are some results linked to my literature. One source shares that technology related to technology and investigate mathematics teaching and learning, and all claim that the appropriate use of technology provides a promising direction for helping children learn mathematics. Another source shares a student's response from interviews, and one student shared that he enjoyed computer math, because computer math made him feel that he was smarter. It made the problem-solving process easier. Some other students feels like that computer math gave more clues. It gives more information, and practice was easy to identify the right or wrong answers, and was exciting to see immediate scores. So here are some implications for future practice. If I was to do a similar study in the near future, I would definitely have a control group and an experimental group. I would have compare one group, both groups having a teacher instruction, along with one class using study Allen as a supplement, and compare it to another class that's not using study Allen, and see how much of an effect study Allen would have on students' math scores. Also, I would like to do a comparison between teacher instruction and Study Allen alone. Compare two classes, one class who had direct instruction from a teacher versus a class who did not have a teacher, direct instruction, who just used Study Allen. And so, as a result, overall, Study Allen has had a positive effect on students' achievement and their attitude while solving math problems.